We will implement a scripted asset action utility that ensures correct compression settings on our textures. Those settings will play a huge role in optimizing your game. Also, you will learn how to modify editor properties of assets and how to use a switch node. But first, let me briefly introduce you to the subject. Correct compression settings help you save texture memory in runtime and also influence actual look of in-game textures. In big projects, there usually is a person designated to defining optimization standards, and this person will decide what setting each texture will use. If there are no automations made for it, artists have to manually open the texture, navigate to compression settings combo box, and pick those settings themselves. They may also pick other settings, like turning on and off this sRGB checkbox. And if at some point the requirements change, they will have to go through all the textures and do it again. Typically, we want normal map textures like this one to use normal map compression, diffuse, albedo, and emissive to use the default, and grayscale would be used by metalness or roughness. There may be some exceptions to this rule, like using alpha compression instead of grayscale, but that is a broader topic. In general, if you are unfamiliar with that, I really recommend reading some articles online, and I suggest that you read multiple ones from different authors because they all may have different things, different takes on certain things, and it is important that you understand what is done why, and then you pick the optimal solution for you. Apart from setting compression settings, we will make sure that this sRGB that I showed you is enabled for diffuse and emissive. And one important thing about it is that you may not always be able to set it. Let's open this normal map as an example. And it uses normal map compression settings. And those aren't just compression settings. They are also settings that may override other parameters. So in that case, I am not able to click on this sRGB and change the value. We have this little asterisk near the name of the texture, and Unreal knows that we changed something, but it still overrides those parameters and it doesn't show us any warning or error. So don't be scared. This is in fact some tribal knowledge, but it works as intended. And if we changed our compression settings to default, then we would be able to change this sRGB. And as you may see, it changes the look of the texture. So explaining this sRGB, we have different ways of encoding color data, and when we use textures like diffuse or emissive, this is color data. It is actual color, and it usually is also encoded in some color space, which in our case is sRGB. So if we want this data to be read properly, it has to be enabled. But that is not the case when it comes to roughness, metalness, normal map, and other kinds of textures, because yes, they store data in color, in channels that are named red, green, blue, but this is a non-color data. In case of normal map, it describes some kind of vector. In case of roughness, it has information on how rough it is on scale from 0 to 1, in some grayscale mapping, of course. But it's still non-colored data, and it should have this sRGB disabled. So we will have it enforced by this normal map. However, if you want to keep your blueprint simple, you can still, in the implementation, be setting this value, and in some cases it will just not do anything, and you will probably see it in my example. So now let's start implementing something, and you may have already noticed that I organized my folders a bit because the number of files started to grow. So We no longer have everything in BP tools folder. Now it also has subfolders, and I created one called automatic texture settings just for the sake of this tutorial. We have 4 textures. I have copied them from starter content, but you can use any images you want. And they probably have correct compression settings, so we will have to change them a little, but we will do it when we will be testing our tool. Now we want to focus on creating the blueprint. So let's right mouse button here, navigate to editor utilities, and we will pick editor utility blueprint. Then let's choose asset action utility because we are modifying assets, not actors. And let's call it automatic texture settings, maybe BP or BP at the beginning. All right, and let's open it and dock the window. I will create a new custom event and let's call it just automatic texture settings. Maybe without those spaces that I have added. And always make sure that you have enabled call in editor. So the flow of our tool will be going like this. We iterate over all selected assets, then we make sure that we only process those that are textures. And then we need some way of defining what kind of texture it is. Is it diffuse, normal map, or maybe something else? And for that, we will follow standard naming convention. So we know that our textures start with T underscore, but they also end with something. Underscore D usually means diffuse, underscore M metalness, underscore N normal map, and so on. There may be more suffixes in different projects because users like to pack their textures in some specific ways. So you may find different namings like MRO or something else, but we will do only the most basic cases. So we will have to split the name, and we usually use underscores for adding prefixes or suffixes. So we will just split it by underscore, and we will be left with this last string of letters like D, M, E, and so on. And then we will switch between different approaches to processing textures based on that naming. So first, let's focus on getting the name suffix. We need some list of selected assets. So let's get selected assets, connect the blueprint flow, and we already have the array we could use for each loop. Now we have to make sure that we are working with textures. In previous video, we were just validating if we are working with certain class of object. And for that, we used isA node. But this time, we will be doing something with the object. We will be accessing methods that are specific for textures, because textures have many parameters, like compression settings, and they can be modified with specific nodes like set compression settings, or we can get it with get compression settings. So in that case, we need features that are specific for specific kind of object, and that's why we are using cast. So we have to look for cast to, and then we say what kind of asset we are looking for. We need texture 2D, so there is cast to texture 2D. And if we use this as texture 2D, then now we know that this is texture to the object. If we go back to array element, we only know that this is an object. And it already makes a difference when we are working in graph. It's not just influencing how the code works, it also influences our work, because if we try to make some node connection from here and place a new node, we have this context sensitive enabled, and we could, for instance, try get compression settings, and we would get a nice hint. But if we did that on this array element, it wouldn't be available. Of course, we would be able to disable context sensitive, and we would get that, but there would be no guarantee that it works correctly, because if this array element was a static mesh, we would get a runtime error. So let's keep it this way. Let's use this cast to texture, and I will remove this getter node that only served as an example. When we are working with such things like cast, we always get a nice exec output if the cast worked, and that is the case when we were expecting to work with texture, we casted it to texture, and it worked because it was a texture. But if it was anything else, it just has this cast failed. So if you want to have different flow of your nodes in that case, then that's the way you do it. So now, as we have this texture, we want to get the suffix like _d. So we need to get our display name, and we have to try some modifications. In programming languages, there usually is a split function that splits a string on some letter or some character. And if we look here for a split node, then we will get something similar. But it may be different than in programming languages, because if we had name like A_B_C, then in languages like Python, we would get a list of A, B, C separately. And this node only returns us left and right side, which may be an issue if we have more underscores. And you will see that in a minute. We have the source string, and this in string will be our delimiter, something for splitting. So let's make an underscore here, and let's test it using some print. We know that the left side is not important to us, so we will just print the right side. And let's connect this flow, let's compile, save, and now we can execute it even on those or full textures. And we got rid of this T underscore, but we still got that brick, clay, beveled, something, something. We can still see it in the log. So we need to fix that. And when we get back to our graph, luckily for us, there is search dir that tells us if we are searching from the start or from the end. If you want to make something more complex, you will probably have to use a loop or more splits and iterate over it. But in this case, going from the end will do the job. So now we can retry, and we only have those suffixes. So that is amazing. It does the job. So if we have those single letter strings, we could use them to control our blueprint. And there are two ways of doing that. We can either use branch, and we would have to have some condition like this right string equals some other string like D or N or M, but we would have lots of nodes and lots of branches. Or we can make it simpler by using a single node called switch, and it expects many different data types. So we are going to work with strings, so we search for switch on string. And now, as you see, this search is really narrowed, and we only have one exact match. It is important to have this right side with details available here, because we are going to add more pins, more flow options, and each of them will be mapped to one of our possible suffixes. We can click this add pin or do it in the details. And we will add N for normal map, D for diffuse, E for emissive, and maybe also M for metalness and R for roughness. So that should roughly cover most of PBR materials. Great. Now let's connect this right S string here, and maybe also let's get rid of this print string. So now we can control the flow, and we could even make some test prints. Maybe let's add two example ones for normal map and for diffuse, because I know I have such example textures. Here is diffuse, and we will print normal map, and here diffuse. Let's compile it and save. And if we try it on those two diffuse textures, we get two diffuse prints. If we try it on this normal, we have this print. And if we try on those three, I'm skipping metalness because we didn't add any print there, it does diffuse normal. That's amazing. The last thing we have to do is actually setting the properties. So let's remove those prints and start modifying our texture. We need a node called set, and then we will look for property we are going to set. If you have no idea how it's called, simply go back to the content browser, open the texture you are looking for, and just look for the name. For us, it's clear when we are following the tutorial, and I'm talking about compression settings all the time, but sometimes you are modifying something else and you just have to look it up. So here it is called compression settings, and there will be very likely node also called set compression settings. It will be easier to find it if you create this node from connection to the texture 2D. Let's look for set compression settings. And here we have it. We can also do same thing with sRGB. Let's scroll down. It's called just sRGB, which makes things easier. And let's make set sRGB. It works fine, great. But to make it all simpler, let's just double click here to make a common node for our texture object. Good. So now just connect those and here, and we'll copy it about 5 times, and then we will set correct settings. This goes here. It goes a bit lower. Amazing. It goes really smoothly, and here we can connect diffuse, emissive, metalness, and roughness. And as I said before, normal map usually uses normal map compression, diffuse and emissive go with default, and metalness and roughness will go with the grayscale. Also, only diffuse and emissive are going to use as RGB. And I know that normal map compression settings will not let me set those sRGB values. You can get rid of this node. You don't have to. Sometimes keeping those settings here in nodes is pretty nice, because if for any reason you decide to change your optimization standards in the future, you will have the same setup for each texture. So instead of adding new or removing some nodes, you will just check on or check off the setting. And before we test our tool, we have to make sure that this texture is connected to nodes that are going to modify it. And there is one last pin not modified, which is called default. And this is what is executed if none of texture fits our naming convention. You can leave it empty, and in that case, it will not execute anything, but you can also add some print with some informational message, because that may be user's fault. Maybe he didn't name texture properly, and that will help him find the issue. Let's also make sure that everything here on the left side is fine. Looks so to me. So let's just compile it, save it. And before testing, we should change those texture settings. So here, maybe let's change it to HDR. Can I check or uncheck sRGB? I cannot, doesn't matter. We can now go to metalness. Let's change it to normal map. Also save it. Now this normal map could be changed to default. We can also enable sRGB if you wish to. And this diffuse could be, we can leave it as diffuse, but uncheck sRGB. So this way we will make sure that this sRGB is doing something and wasn't enabled automatically when we changed compression settings for some reason. Because as you can see, it doesn't change it when I change the compression settings, but sometimes there is some callback that does this kind of things. And one last thing before running our tool is that you should close those editors with assets. Very often when I make automations for Unreal, they do work, but they don't refresh editors with assets. So users come back to me and they say that things don't work, but if they close the editor and reopen it, it looks like it is all fine. So let's select those textures, and we can even copy some shape from starter content just to make sure that there is no error when we work with static mesh. Right mouse button, and then scripted asset actions, automatic texture compression. It refreshed the look of textures. We can start opening them. So this diffuse has default with sRGB, amazing. This metalness has grayscale with disabled sRGB. Oh, and also the preview just refreshed. Normal map is back to being normal map with sRGB disabled. This T-break clay is also fine. And if we open the output log, there is no errors. So nothing went wrong when processing our shade pipe. But also remember that if you want to limit use of your scripted asset action just to a single type of assets, just go to class defaults and to supported classes, and you can pick texture 2D. I just wanted to show you that this cast to texture can be also used to limit kinds of assets we are processing, and it does serve some different purpose than using is a node. But I do plan on making a separate video on that. I just didn't want to introduce it too early, because explaining complex topic is not the right thing to do when we are starting with the basics. So I hope you learned something new. I really wanted to introduce some new mechanics to you, because I've shown you how to use branches. I showed you how to use data tables, and I also wanted to make sure that you know how to work with switches. But a little comment from me is that when I was researching and preparing for recording this tutorial, I initially wanted to do everything using data tables. But data table requires using some structure, and I will demonstrate you quickly that if you have this structure, you cannot really use compression settings here for some reason. There is something like ABC compression settings, but texture compression settings are not exposed to be available in structures. So I was thinking about doing it in a different way. And honestly, when we think about ease of introducing changes, it's not as bad as you may think when we use those blueprints, because this is not a very complex graph right now. If we were growing it, it would be really bad, but right now, if you really want to just change compression setting, it is quite fine. The only issue is that when this graph starts to grow, this is the only thing you can see, and you no longer see if this is going to be normal, diffuse, or something else. So for that, you can just select those nodes, press C, and now we can write a comment that this is a normal map. And you can also go to details and use some color coding. So I hope it is helpful. You can also move this very freely, so you no longer have to take care of some selections. But if moving everything at once is annoying to you, just press Shift and you can move only this comment section. So I hope you also find it helpful. And that is it for today. See you in the next video.